This is the real Tom Rose, and we're dealing with a function interpretation problem that is interesting. We've been given a function, and we're asking which of the following could be the equation of the graph above. And they're implying that there are many equations which could match the graph above, which is true. So we're faced with a kind of an interesting task. And the game here is really not how to get the right answer. The game here is how to get the right answer quickly. So what we're looking for is shortcuts. And let me give you a couple of shortcuts for dealing with quadratic equations or parabolas. Now this looks like a parabola, so I'm going to make an assumption that it is one. It's not an enormous assumption that I'm making because I'm actually checking the answer choices and realizing that every answer is quadratic. Okay, so this is an assumption, but it's not a giant assumption. Here's a shortcut when dealing with quadratics. If you look at where the function crosses the x-axis, those are the points where the function is equal to 0. Quadratic functions can be expressed as the product of two binomials equaling 0. And the only way for that equation to equal 0 is if one of the binomials itself is equal to 0. And we actually need the condition where both of them are equal to 0. So what is the case? So here's the game. Can you build a binomial? And a binomial, you'll see an example of binomial in a second when I write an example. Can you build a binomial such that when you put 1 in for x, its value is 0? And so let's see if we can do that. X minus 1. How about that? If I put 1 in for x, is the value of this binomial 0? Yes. So this is a potential binomial. Let me plug it in. And let's do another one. So let's go for the right circle where our function crosses the x-axis. That's a point where we know the function should be equal to 0. So I need another binomial, which when we plug in x of 3, it's equal to 0. So I'm going to pick x minus 3. And let's test it. If I put 3 in, minus 3, is that equal to 0? Yes. So that's a binomial that I like. So this is what we just did, is we built a function which could be an equation of the graph above. Now we don't know at this point that this function is going to match one of those. But I have taken a leap of faith that the SAT is going to provide an answer which is relatively easy to find using this technique. That's a big leap of faith, and if it doesn't work, we may have to bail out and choose a different technique. But let's keep plugging away and see what happens. I'm going to take this function now, which doesn't look like the answer choices that we have, and try to convert it. And the answer choices, you'll notice, don't have any parentheses. So what we really need to do is FOIL this result. FOIL stands for multiplying the first two things by each other, the outside things by each other, the inside things by each other, and the last two things by each other, and adding that all up. Right? First, outside, inside, last. FOIL's an acronym. So let's FOIL this. And let's see, we do x times x, we're going to get x squared. Negative 1 times x. Or let's do it in order. So the outside would be x times 3, which would be, it's actually x times negative 3, so we'll get negative 3x. The inside is -1 times x, so we'll get minus x. And last will be -1 times -3, which is actually positive 3. So here is a potential function. It hasn't been simplified yet, but that could represent the equation or the graph above. And now let's simplify this. Collect like terms. X squared minus 4x plus 3 equals y. And whew, we got lucky. X squared minus 4x plus 3 is in fact on our list of answer choices. That's answer choice A. And this is how I would do this problem on the SAT. I would take that leap of faith.